So this is for assignment vectors assignment question 3. We are looking at relative to origin. The position vectors of the points A, B, and P are -1, -3, 2, 5, 2, 0, 1 plus 2 lambda, lambda minus 2, and 2, where lambda is a real number and not equals to -1. Right, we first need to show that A, B, and P are collinear. So how do we show collinearity? Very simply said, in the visual sense, we want to show that A, B, and P, right, they are actually, right, they have the same direction vector. Okay, or can we say that basically we just need to show that they are scalar multiples of each other. So one way to go about doing this, we can just show that AB, right, can be a scalar multiple of AP, for example. Right, so if you can do this, then we can end past it. They have the same direction vector, and they also share a common point. Very quickly, we can show that they are collinear, meaning they have the same line. Okay, so this is the idea that we are doing. This is the direction that we're heading towards. So first, we need to do is we need to find what is AB. What is AB? Okay, we know that. Let's quickly write down our numbers. OA is equals to -1, -3, 2. Right, OB, this is equals to 5, 2, 0, and OP, right, this is equals to 1 plus 2 lambda, lambda minus 2, and 2. Okay, so first quickly let's in this direction. Let's look first find AB now. Okay, so what is AB? AB will be equals to OB minus OA, right, and 5, 2, 0 minus -1, -3, 2. So it's 5 minus -1, I have 6, 2 minus -3, so 2 plus 3, I have 5, 0 minus 2, 6, 5, negative. This is my AB. Okay. Wait, have I gotten it wrong? Oh, sorry. OB is actually equals to 502, not 520, 502, because 5I and 2K. Alright, so this one should be equals to 502. Yep. Okay, no wonder I got it wrong. Okay, so the final answer, 5 minus -1, this should be 6. 2 minus -3 should be 3. 2 minus 2, so I should get 0. This one should be my AB. What's AP? AP would be OP minus OA, right? So very quickly, AP, this will be equals to OP minus OA. Alright, OP, as I found earlier, this would be 1 plus 2 lambda, lambda minus 2 and 2. 1 plus 2 lambda, lambda minus 2 and 2. Then OA will be equals to -1, -3, and 2. Alright, so solving for this, I have 1 plus 2 lambda minus -1, I have 2 plus 2 lambda. Lambda minus 2, I get a lambda plus 1. 2 minus 2, I get 0. Alright. So if you observe this, the idea is that we want to show that this is a scalar. We want to show AP to be a scalar multiple of AB, or AB to be a scalar multiple of AP. Okay, either one is fine. Looking at this term 630. Alright, going back, we want to show 630. Is it possible that this can be a scalar multiple of 630? Okay, so let's try. Okay, actually it's possible, right? So what we do is observe for this, we can actually take out lambda plus 1. Okay, so we have 2 inside, and if we take out lambda plus 1, we'll have with 1. Take out lambda plus 1, we'll have with 0. Right, so we can actually write out lambda plus 1 as a scalar multiple. Now 210, recall that AB is equals to 630, right? So comparing these two vectors, scalar multiple, yes. Okay, so we just need to times 3 times 3 and times 3, and we divide by 3 outside. Right, and AP can actually be rewritten as a lambda plus 1 over 3, 630. And you can see that indeed this is the scalar multiple of AB. Alright, so therefore shown, we have written that this actually is a scalar multiple, lambda plus 3 plus 1 over 3 of AB. Right, so it's not easy, but the important part for this part is the portion you need to know what's collinearity, how to prove collinearity, and how to show force a scalar multiple to appear. Right, so this is for question 3 part 1. So how about part 2? How do we find the value of lambda such that P is on the line BA? Right, so next question, we need to find the value of lambda. P is on the line BA produced, and the area of triangle OAP 162 square root 5 square units. Right, P is on the line BA produced. Area of triangle OAP. Alright, area of triangle OAP. What we can do is we can area of triangle OAP. Alright, very quickly we can just take the area of our triangle OAP. We can take it as a half magnitude of AO times AP. Okay, and very quickly let's compute this. AO would be actually the negative of OA, so it will actually be 1, 3, negative 2, right? 1, 3, negative 2. Okay, and AP, as we have found earlier, right, this is actually lambda plus 1 over 3, 630. Alright, remember just now we found this, right? Okay, lambda plus 1 over 3, 630. So over here, what we do is we just plug it in. Let me rewrite this neatly. Okay, so after that, we know that this has to be 162 square root 5. Okay, because the question says so we want to find the value of lambda. So the area of triangle is 162 square root 5. 162 square root 5. So from here, scalar multiple, we can pull it outside. Doesn't matter. So lambda plus 1. We rewrite this as lambda plus 1 over 6. And 1, 3, negative 2, scalar product with 630. Okay, again, we can take out some more here. Okay, 630, we can take out another factor 3, right? So if we take out another 3, we can rewrite this as, if we take out a 3, we can rewrite this as 3 bracket 210. And we pull this 3 outside, we multiply by 3. Okay, if we pull this 3 outside, alright, then I can end up with 210, and here 3 over 6 becomes a half, so I end up with lambda plus 1 over 2. Okay, and over here, finding the vector product. Okay, I'm going to leave it to you. Okay, I'm sure you can do it by yourself. So I should have 2, negative 4, and 5. Okay, and you realize that the magnitude of this should give you should be equals to 162 square root 5. Okay, 162 square root 5. Okay, so you know that 162 square root 5 is equals to modulo negative of 1 over 2 and negative of 2, negative 4, negative 5, correct? So let's slowly try to find everything. So maybe I can bring the 2 across. So this becomes 324, right? So 324 square root 5 magnitude lambda plus 1, right? This is 2 square, 2 square plus negative 4 square plus negative 5 square. So lambda plus 1, 4, 16, 25. So you end up with 4, 16 will be 20, 20 plus 45, right? So you end up with square root 45. Right, 324 square root 5. Right, and you can divide by square root 45 here, and I cancel this off. Right, this means that if you simplify this, right, the 324, right, this would be for 324 square root 5. The denominator you can write it as square root 5 times square root 9. Square root 9 will be equals to 3. Right, 324 over 3. Right, 324 and 3 can cancel off. You get 108. Square root 5 and square root 5 cancel off. Right, so you can just get 108 on the left hand side. This means that lambda plus 1 is equals to 108. This means that lambda plus 1 equals to 108, or lambda plus 1 equals to negative 108. So lambda could be negative 109, lambda could be 107. Alright, so we have two values. However, you remember that P is on BA produced, right? Because P, this is B, right? This is A, right? P somewhere here probably is on BA produced, right? So this means that actually AP, right? And we say that AP is a scalar multiple of AB, right? But if you take a look, actually AB is going in this direction, AB is going in this direction, alright? So this likely suggests actually your K, right, is a negative. Most likely AP is a negative scalar of AB, right? So from here, right, we actually deduce that, and you have two values of lambda. Do you think you take both? You really need to observe the direction of the vectors, right? So K over here, actually K is negative. Why? Because you can see that AP facing one direction, AB is facing the other direction. If they are facing different direction, their scalar multiple of each other can, but the scalar multiple is negative, oh, okay, so K is less than 0. So that means what? If you look at look at this, which one is it likely to be? Most likely is the negative one, or lambda is equals to negative 1 over 9, because the lambda was part of your scalar multiple earlier on, remember the lambda was somewhere here. This is the lambda, right? We want this to be negative, so you want lambda plus 1 over 3 to be negative. Likely is that you have two answers, but lambda most likely should be negative also. Okay, so over here we choose out of these two, we choose lambda to be negative 1 over 9. We don't want the positive answer, so lambda is negative 1 over 9.